So the assignment said, assign a value of 3 to the variable x on the command line. That EG, by the way, it's okay if you don't know that, like scientific writing, EG means for example. Don't ask me what it's abbreviated for. It just means, for example, x equal 4. Yeah, some of you guys got confused. My bad, so I should have deleted it. But you assign the value of 3 to x, then find the square root of x using the MATLAB command line. Then what is the cosine of the square root of x? Then you save the script. I understand I didn't tell you how to save the script. It's fine if you find your way around it. It's fine if you just screenshotted your screen to me. Either way, I just wanted to play around and feel a little confused about it. But I think you got it. Okay, with that being said, so x equals 3, then you have square root, then you have cosine the square root. So, as we did last time, x equals 3, we assign the variable x, number 3. Then, to find square root, you hit SQRT and you see MATLAB start to suggest stuff for you. SQRT of x, close parentheses, and enter, that's 1.73. Then find the cosine of the square root of x. Here, there's many ways I can do it. Which way did you guys do it? Did you just, what did you do? Like, I could say cosine the answer, and it will be the same. I could say cosine, from the first, cosine this square root of x all in together, and give me the same answer, right? Which way did you guys go?
Put cosine, parentheses, square root, parentheses, x.
Okay, so you did one line. Cool. So you could say either cosine the answer. I can use the word as anytime as long as it means the value I want. That will give it to you this way. And if we clear everything and go all the way back, clear and CLC will clear everything as you are in a fresh start. Then I would say x equal 3. Then I would say SQRT, I mean cosine, if you want to be smart about it, the SQRT of x. This expression will give you a final answer, same as what we did before. Is that what you got? Yeah. Okay, cool. Now we can start our presentation then. Okay. Let's see if this is working. So I want you to type in while I'm presenting here. So we're still in Explore MATLAB. Last time, you know, we got a little slow. So we got to go a little faster here so that we can catch up with our lecture. So we talked a little bit about arithmetics, how to add, how to subtract, and all of that. Then we learned how to assign variables, used a little bit of mathematical functions. Then we did functions and commands and a little bit of vectors. Now let's try to do this. I think we did it a little bit last lecture, but let's do it again. We're trying to create an array, x equals 0, column, a step of 0.1, column 10. Go from 0 to 10 with a step of 0.1, doesn't matter how long you go. The important to reach 10. Then you get y, you guys type in, y equals sine x, then you plot x, comma y, then comma grid. We said grid stands for you have lines of grid that's guiding your drawing. Try type it in and give you a minute. See how it goes. When I see a graph, you're good. I think we did it last time, I'm not sure. When you finish, try to do it again without grid, like just plot x, y, see what's the difference. Just make sure grid means really grid, nothing else. Okay, so now let's add those lines as well. We want to create a graph similar to this. This is just only for you experimenting the power of MATLAB, you know. So try to copy it. I wish we are online, then I can give it to you in the command or in the chat. But so plot x, comma y prime, then dash rs prime, then line width 2, marker edge color k. Then you go x label, y label, then white back, then you should get this, and we will explain each segment what does it mean. What you're trying to do here, you're trying to plot x and y. Then you need to have along the line, you need to have each point to be dots and connected through a line, and here you are defining the line width to be 2, then the marker edge color to be K, there is a code for each color, then the marker size, how big is the line, you choose number 5. Then comma grid to give you the grid for the image. Then the second line, when you say X label X, means label the X axis with X, Y label sign X, label the Y axis with sign X. You good? Take your time. So this kind of exercise is a little bit advanced to you, but to give you an indication about the power of MATLAB. So even though it looks kind of, instead of having just basic line, you can play with the line, even though you want to do it through code. You know, when you have Microsoft Word or in any other software, you can use the mouse to create dots and stuff. But here, you are letting him create the graph you want in the manner or the way you want it through the code only. That's the beauty of it. Sometimes you're writing a certain code for a certain application and you need the graph to look in a certain way. You can't go to another software and do it like in a graphing or drawing software. You got to do it through the code so you can make your code and the result of the code look nicer and better. On your own, you can play like with line width 2, put it 4, put it 5, and see what happens. Marker edge color K, put it W, put it M, see what he gives you. Marker size 5, let's put it 7, 8, 9, 10, and see how it goes. X label X, put it X label your name, whatever you want. Y label something else, and see, does it change here or no? Just change one thing at a time and see what happens. As long as you don't take an error or a mistake, then you should be good. Did we try the tan together? Let's try this together. X equal 1 as an array. We're creating an array from 1 to 10, same concept with an increment of 0.1. Let's have the z to equal tan of x, and we have a simple plot of x and z. We are used to x and y, same concept, but in this case you assigned it to z. Then you're giving the axis. We're going to talk about those in details later, kind of blindly copy it now. 0, 10 to 10 to 10, and see what happens. Could be boring for some of you guys, but it's just having your hands and your head around MATLAB, feeling comfortable, plugging in the variables and drawing a plot, closing back the plot, and trying to see how much room do you have to change the properties of a plot. How does cotan look like in MATLAB? How does sine look like? We know how it looked like on paper, on book, but how to get it, how to do it on MATLAB. That would make you like kind of, without thinking so much in the future, you'll be able to do plots and assigning variables and so on. Right? How about if you add easy plot, tan x, easy plot is like the simplified version of the plot without many details. So he just show you the tan x without many details. In the previous plot, you just told him what you want on the axis, how many degrees to show. Here it's like zoomed in to the tan for the easy plot. You did the easy? Yeah, it's like zoomed in, while in the previous one, you were like telling him exactly what to show you, how far, because you can keep zooming out for infinity while looking at the tan. Now let's try to learn how to solve a system of linear equations with MATLAB. Anybody have a problem or didn't heard about linear equations, just in case? It's like you have two equations, x and y. You need to find the values of x and y. Now, to be able to solve the system of linear equations, there's two ways on MATLAB to do that. The first one is the matrix method. It's kind of, you put your things in a matrix style, same as your scientific calculator. Let's do that together. So if we say A equal, so what's in the matrix of A? We didn't learn about matrices, I understand. We're going to go in details in it, but for now, just show you the power of MATLAB. So have 1 space 2 semicolon, then 2 space minus 1. This is not 2 minus 1. This is 2 space minus 1. And go to B, same thing. Then you are asking him what is x equal A divided by B. creating matrix A and matrix B. In matrix A, we have 1, 2, and 2 minus 1. In matrix B, we have 4 and 3. Then you are dividing A matrix on B matrix. Then you will get the final results. This way, he solved for you for X and Y. When you do that, I'm going to go back to it and explain to you what's going on. So here you have two equations. X have a factor of 1. It's like 1 by X, right? Plus 2y equal 4. That's the first equation. The second one is 2x minus y equals 3. Now think about these two equations as the coefficients of x and y in the equation. So x have a coefficient 1. We bring it to the matrix and we give it 1. Y have a coefficient of 2. We put it here. Then comma means like go down one line. Semicolon, I mean. Then you have the factor of x in the second equation is 2. You put it here. And for y, it's minus 1. You put it here. It's like you're telling the program, I have two equations in a matrix form. A with the factor of x is this, and factor of y is this for equation 1. And for B is representing what's after the equal sign. So B is representing 4 and 3. This is a semicolon, not a column, right? Semicolon, okay. Yeah. So it's like you draw a matrix, then you have 1, 2, 2 minus 1. All of these are representing the factors for x and y, and you are writing another matrix with the what's after the equal sign, so 4 and 3. Then when you divide these above each other by mathematics, you will get the final result to find the value of x and y. As simple as that.
So if there's more variables, you just add to that?
Yeah, like let's see, you have x plus 2y plus z. Then you would add 1, 2, then you add 1, then semicolon, and you continue. Now the other method that you can use, which is the method really everybody is using in MATLAB than that one, is through solving systems of equations. How you tell MATLAB that there is a system of equations I want to solve? You tell him SIMS. That's you're telling MATLAB, hey, I'm going to solve a system of equations, means more than one equation. While in this system of equations, the variables are x and y, and I'm trying to find the value of x and y. Here you start to write your equation. Solve, open parentheses, you go up there and you copy, but in the MATLAB language. So MATLAB doesn't recognize 2y. He will always give you a mistake or error. He always needs you to have an operator in between variable and constant. So you go x plus 2 multiplied by y, as you see up there. Then you move the 4 to the other side. You can't put equal 4 here. It's going to give you a mistake because MATLAB can't understand it. Minus 4, as you move it to the left side, equals 0. So it will stay this way. The other one, 2x, 2 multiplied by x minus y. Instead of equal 3, you move 3 to the left side, become minus 3. I'm assuming you guys know that from the math. Then the command whose, he will tell you how does the system look like. When you make a matrix, then you write the command whose, he's going to show you how the matrix look like. When you are having an array, then you say whose, he's going to show you how many components in the array, and so on. Now you're telling him x equal double x, so the value is a double integer. That's what it means. Y equal double y, so whatever the value, give it to me as a double integer. Then he asks whose, that means show me the explained result. So we get the sims, then space x, space y, then you get your semicolon, then you open a bracket, x, comma, y, equal, solve, open parentheses, now you start to write your equations. X plus 2y, so I would say x plus 2 multiplied by y, minus 4, because we move it to the left side, as we mentioned, and as we know in mathematics. Then we say 2x, so 2 multiplied by x, minus y, minus 3, because we move the 3 on the right-hand side to be on the left-hand side. So that's how MATLAB works. You can't solve it for you with equal sign. You've got to play around and adjust it in a way that you can understand. So since x, y, just make sure x comma y, okay, it's plus 2 y, let's go. Now you got x equal 2, y equal 1. Take a while, depending on the computer. It seems like not a very fast computer here. Then we say whose, like show me what's going on. Now he show you x with a size of 1 by 1. By the way, this is replication of what's in the workspace. In case you have workspace on the left side, you need to do that. Sometimes you don't know what's going on, what's the variables behind the scenes, so you look at it one more time. So you know that x is allocated 1 by 1 value, so it have 1 value, and y have another value. X equal 2, y equal 1. That's for whose. Now, let's say x equal double x, then comma, y equal double y. Then you hit enter. So that kind of command, the double, sometimes you have 1.45521 and so on. He's just trying to give it to you in a double kind of format. Then we can ask whose one more time, and he's just confirming that thing, and he's telling you the class from the system class, it is now a class of double. The variable inside x is considered a double class, and same thing for y. That's it for that. That's clear. And go back. Now to confirm your solution, you can ask him x plus 2y. Now you have the value of x and y, so you can plug in your equation as it is. Does it equal to 4 or no? So x plus 2 multiplied by y, does it equal to 4? Because now he already solved the value of x and y, so he can replace x value is and y value is, then he should be able to give you, like if the x is 2 and the y is 1, so 2 plus 2 by 1, that should be 2 plus 2, which gives you 4, so you know that your MATLAB solution is true. So let's say after we learn more about system of equation in the exam, I asked you solve these equations, you want to confirm your solution, you can do that at the end. Now we want to talk more about the MATLAB editor. So we have home. Obviously in front of you now there's home, plots, and apps. But there's no editor. How to get that? Editor is the way where you can write your program as a whole, then edit in it, and run it at one shot. Like when you're ready, what we wrote previously, instead of hitting enter and get the final result, you can look at the editor and edit the lines of code and run it all at once. Let's look at it together. So now we have home. What you're gonna do, go to new. Hopefully there's editor in this. Then new script. Now you can see, you see new Windows, editor, publish, file version, view, and so on. So here, if you write x equal 2, hit enter, nothing will happen. Like everything is editable. It's like your notepad. You know, if you hit enter, does nothing unless you run the software. So let's go together. X equal 2 with a semicolon, then y equals 5 with a semicolon. And I would say z equals y divided by x. Now I hit enter as much as I want, nothing happens. So now it's like your notepad, exactly. You're writing stuff in it, but it means nothing until you run it. Sometimes while you're programming for a certain problem, you need to write a code and look at it in a whole. Maybe you can go back to the command line, execute it, and see what happens, and come back here to edit it. When you finish your code, you can run your code. How you run it? Now to run your code, same as what enter was doing in the command line, you go to run, or you hit F5. That's gonna run the code for you and give you the result, same as what enter was doing in the command line. Hit enter. Now he's asking you, what is the name of this? .m. That means it's a MATLAB file. Okay. Then he's running. You see here the x value is 2, y is 5, z is 2.5. So now let's redo this and learn how to save our script. Let's say we're writing something here. We don't want to run it. We just want to save it. So you go to save. So that's your code. Doesn't matter if you run it or no. If you run it, then you assign values here in the workspace. Like x will have value, y will have value. But if you're still in the writing of the code, you can go to save. Either save, then he will ask your name as he did for us to have test.m, or you can say save as. I want to save it at a certain place with a certain name. Let's say we have it as test2. Then you can do a save as and do that. Again, always make sure you're in the right directory. So the current folder here is at my site. It seems like it's on the cloud. There's a MATLAB drive where you are saving your stuff on the drive because you're using an online version of MATLAB. But if it's on your PC, then you're gonna see it on your PC C/something and so on. Okay. That's for the editor. So you can write stuff. It's your notepad. You write stuff in it. When you're ready, you hit run and you run the code. There's a script here. I don't want you to go through it. I thought we will do it online and I'll give it to you in the chat. But I was just planning to let you run it and play with it, try to edit it, see what happens, try to save it. If you run that script, you're gonna find value of A, value of AI. You're trying kind of predicting a matrix in this case, but it's not very important. Now, additional features for MATLAB. You can create what they call it in MATLAB as the magic square. It's like 10 by 10 kind of matrix. If you write the command magic 10 in your MATLAB, then you have equal rows and columns, and the main diagonal would add up to the same value. That's what they call it as the magic bar. It's like, I would say the programmers were playing in this case, but you can try it out. Good to know. Another thing to try, you can try contour, then between parentheses magic 32. So instead of having a 10 items matrix or a box, you're having 32 items box. Go ahead and try it, see what happens. After that, we'll try to gather this one. So we said magic 10. We don't want in the editor in this case, we want in the command line. What you got? You got a 10 by 10 box. Then the diagonal numbers would add up to each other. What if we get contour? Contour magic 32. What's going to happen? Let's see. You got that interesting mathematical graph. You're kind of creating a contour for the numbers based on the value. Let's say the low numbers are light blue, the high numbers are yellow or purple, and so on. You can do pretty much a lot of stuff with MATLAB. People who, there's nobody know MATLAB. There's somebody who experienced a good amount of MATLAB, but you always try to learn something new. There will never be a hard stuff where you would learn MATLAB. But the more you know, the stronger you are in MATLAB, a better engineer you are in the market and the industry. You can need that for a lot of applications. Now let's try this. X and y equal mesh grid minus 8 with increment of 0.5 to 8. That's an array with a mesh grid. Now R would equal the square root of x to the power of 2 plus y to the power of 2 plus EPS. Again, just do a kind of blind application and see what happens. You should be able to get a graph similar to this one. Z would equal sine the R. Then we told you dot means if there's any, like dot before the division, we will divide above any component of the array for the same value. Sine R above R1, sine R above R2, or divided by R2 and so on. Then mesh Z means give it a mesh, that kind of lines that you see around the contour of the graph. It's a practical course, a lot of silence moments. You gotta take your time and make sure you are comfortable with all the properties and apply as much as you can from those scripts. You know, applications for this kind of graph, that's something I experienced myself. Like there's something called torsional vibration analysis. When you are having a spinning machine, or let's say the gearbox in your vehicle, if you analyze it, when it's in the factory, before they put it in the car, they analyze it, they put accelerometer, like those are kind of sensors that detect the vibration. When you are detecting the vibration, you gotta look at the whole thing. You get maybe 40, 50,000 lines of data. You can't look at them by numbers. Even whatever conditioning statement you put in Excel, still not enough. So what you do, something called waterfall graph. Waterfall graph will show you all the harmonics and the vibrations. Let's say you have X, Y, Z. So X and Y and Z. Let's say Z is the displacement of the vibration, and the X, let's say the acceleration, and Y is the time. Then you will see kind of waterfall of the vibrations along the powertrain or driveline. This way you can tell if the vibrations are too bad or too good just by a picture. So that's one application for this. Again, you did a blind application here. I don't expect you to know every bit of it, but just to know that you can create such graphs. You can go very sophisticated with MATLAB graphs. Then MeshZ, I will tell you, MeshZ is the one who's responsible for giving those lines on the graph instead of being pure 3D. And of course, you know the grid. When you have mesh grid, those are the grids for the XYZ graph. All right, next we're gonna go to apps. If you look into your MATLAB online as well, they have it. If you click on apps, good to know. I don't know if we'll able to ever go to that. The thing is, the MATLAB, they created a concept where you create a code. If that code is doing a certain calculation, you can convert it to app. Like in the future, you write a script, it does certain things. Let's say units converter. You can convert from metric to SI units to so on. That kind of code that you did, let's say he can convert in no time, or it's fast, or so on. Then you can create an app. That app, you can have it on your machine, run by itself, but you need to have a MATLAB on the machine. Or you can share it with people. If it's really a good app, you can maybe talk to MathWorks, and they can take that under their umbrella and put it here. So somebody did curve fitting, so he go and he write a very long script where he can do a good curve fitting for any graph that you have, or for any data set that you have. And either it's the engineers of MATLAB or MathWorks who did that, or maybe some company or a group of researchers who did that, and they propose it to MATLAB and they put it under the umbrella of their apps. Those are not a PC apps, not a phone apps, as I mentioned before. They are apps for a certain applications. Like you can do optimization, PID tuning. If you have signal analysis, then you can do signal analysis for your data, image acquisition, Neuralink, I don't know, MBC optimization, I never saw that, distribution fitting, all kinds of apps, and there's online apps and in the software apps. So you can look at them, some of them are helpful. Back in time with General Motors, we had, as I told you about the vibration analysis, the machine at certain speed will start to vibrate very bad, that the machine will break down if you keep it overnight. And in some cases, the sensor can't read if this engine or this transmission is a good transmission or no, because you're depending on the sensors to tell you if the transmission is getting loud, getting noisy, and so. So when you go through harmonic vibrations, that's what they call critical speed. Like if your vehicle is not designed to specs, it's gonna vibrate very badly that you can't tell if it's a good engine or a bad engine, or your transmission is gonna fail. Like now, if you hear your car having high transmission sound, you're gonna go to the mechanic because you think it's gonna fail. But the thing is, there's nothing wrong with it. It's just having problem with harmonic vibrations interfering with your speed. So what we did, we create an app similar to this where the engineers can open the MATLAB, click on the app, and plug in their numbers, like what's the weight of the transmission, how long it is, how many gears in it, what's the size of gear, just some details as input. He hit enter, then he will be able to tell, okay, avoid these weights or these speeds to be able to avoid high vibration amplitudes. That's one of the applications we did before. Now let's go back to the graphs. Let's do a sample program together in the editor. So go to File, New, Script, so that you can see the editor and start to write this code. X equals 0 to pi over 20. Make sure you clear and CLC before you do that, because maybe you changed the value of pi before. Plot x, comma, exponential of minus 0.2x, and multiply it by sine x with a grid. What you're trying to do, you're trying to plot the graph of this function. X equal 0, column, pi over 2, column, 6 multiplied by pi. Okay. Now we say plot x, then the exponential of minus 0.2 multiplied by x, closed parentheses, dot multiplied by sine x, means every component, if you have more than one value, to be multiplied by the exponent of minus 0.2x. Sine of x, comma, save, okay, close it. We have comma, then grid. Just add the grid to my graph, hit enter. Now we got a similar, probably could be better, but it's not very detailed graph for the exponential of minus 0.2x multiplied by sine x. So one more time, let's go to the editor. New script at our editor. Let's say we said I don't want to make it complicated to you. X equals 0 to 1, and y equals 1 to 5, and let's say plot xy. I'm not sure if it's going to plot anything meaningful. Maybe it's just a line. But what I want to care about here, you did your code or your script in the editor. Just I want to go over saving one more time. And save or save as. Save for the first time, then I ask you for a name. Save as, in case you have a name, but you're going to change it to the new. If you did any change to the script in the editor, then you can do that. And you can see all your MATLAB codes here. And you can come back to them by double clicking on them. It will open beside this as a tab. You can see test 2 is opening. There's test 3, which we were working on seconds ago. You can open test.m, same thing. Edit it, save it again. So f equals 3. Then you can save it. So test.m will have new values and so on. Whenever you feel you're ready to run it, you can run it. But if I ask anything in the future, that's how you go in the editor. And you save it. Either I ask you to run it and show me what is the result in the command window, or I can just ask you just to give me the edited script. That's that. We already covered how to save it. Now, as a summary, we finished with this chapter of Introduction to MATLAB. So MATLAB is a matrix-based computer system that's designed to help you and assist you as engineer and scientist in your problem solving. You can use your MATLAB to enter commands and statements on the command line, or you can go to your editor and be able to edit it and run it whenever ready. And whenever you write in your code quit or exit in your terminal in the command line, you're going to close MATLAB. CLC, as we mentioned, clears the command window. You can always type in or look for help by typing in help, or you can look for, in a certain thing, you can try to look for variables and you can read about variables, but I'm sure you can access that without the command line. Then plot will help you to draw stuff, plot x, y, in case you have x and y as equations or as arrays or as variables, you are able to plot how does x and y look like. Grid will draw a grid line along your graph. Right, now we're moving to MATLAB Fundamentals. Now anything we learn, we cover here. We are not into introduction anymore. Anything we cover here is a serious topic, and we expect you to know about it, all the details. We will talk a little bit about variables and operators and expressions. All of these we touch base on, but we will go in details. We will talk as well about arrays like vectors and matrices. We will talk about basic inputs and outputs. We will cover as well repetition, or what's known as for loops. Then we will talk about decision, which is like the if statements. Now again, we will go through variables. As we know, variables are very important in the programming languages, in any language basically, and MATLAB it is very important. So if you would conclude what is the variables for the programming, it is getting the right values in the right variables at the right time. Now, you can give any name for the variable, but there is a certain variables kind of rules that you should avoid when you are making a new variable. First, your variable should consist only of the letters A to Z and digits 0 to 9, and it can get underscore as well, and it must start with a letter. You can't say variable 9b. You can say variable b9, but you can't say 9b. The name can be as long as you want, but for MATLAB, he recognized the first 63 letters of your variable. I don't know if it makes sense to make very long variable, but sometimes you need it. To know what is the maximum length that MATLAB can recognize in your machine, you can type in name length max in the command window, and you should be able to see how many characters does MATLAB recognize as a variable definition. Now, for invalid variables, so we said it should be letters, should be numbers 0 to 9 with underscore. Anything else is invalid. So now we have here two groups. One is valid variables, the other one is non-valid variables. So we have the variable R2D2, and we have payday. Let's say you want to say R2D2 equal 1. Does the MATLAB like it, or he will say no? Same thing, pay underscore day. Does it like it or no?
Yeah.
How about here? So which ones is the problematic variables based on the variables rules that we read about MATLAB?
One at the bottom.
So the one at the bottom is the one have problem.
We do that, yeah. Name,
Why?
$sign. Can't have that.
So you can't have $sign. You can't start with a number. You can't have a dash, I believe they call it dash. You can have an underscore instead. Now, we already know that, so we learn how to assign a variable with a certain number. So if we say A equal 98, but if you are referring to a variable that you never assigned any value to it, as you saw previously, maybe last lecture or something, you called the variable B, let's say Z equal B, but you never assigned a value to B, then you're gonna say, or you're gonna have an error letter saying undefined function or variable. For the variables case sensitivity, MATLAB is case sensitive, which means it have a problem, or it can distinguish between upper and lower case letters. So there is a difference between balance in small letters, and there's difference between balance capital letters and a combination of both. So if you say now in your MATLAB, go ahead and say balance small letters equal 1, and say balance capital letters equal 2, and look at your workspace. See what is the values of small letter balance and capital letter balance. If he sees them the same, you're gonna see the final value for balance for capital is the same for both, because he recognized them as the same. If there are two different values, that means he differentiates between both. Now there's a beautiful thing in MATLAB as well. In your workspace, you can add commonly used constants. Like MATLAB, he didn't know what's G, that equals 9.81, the physical G. He didn't know what's the Avogadro number. He didn't know what is the base natural log. He didn't know what is, let's say you can say, okay, he know pi, that's the only thing he know, but you can say pi underscore 4, that's for your logic. You know pi underscore 4, I need it to be pi over 4, because I used a lot in my calculation, and so you can assign that. Now let's write those in the editor. Go to the editor and write those, not in the command line, in the editor, and save it as constants. Better number equals 6.02. Power 23. Then you have your t equal the exponential of 1. And you have pi underscore 4 equals pi divided by 4. So we got these. By the way, if you want to comment inside your code without being involved in the program, then you can use this sign of percentage, and you can write whatever you want. So that's kind of the commenting out abbreviation. So acceleration of gravity. Say and so on. So now we can save it. Save as constant. Now I had it as a .m program down here. Now what's the beauty of this? Let's say I clear. I'm totally new. But let's say I close this. I have a new script. I'm writing totally something else. But I need those. Like let's say I want g divided by 2. In my editor, I want, I don't know, I'm doing some calculation. Let's say that the equation of speed or any other things that need the Avogadro constant or the gravity constant, all those constants. Let's say I want cosine the 2 pi. Then I can say, or the 4, the pi over 4, then I can say, did we say pi over 4? I forgot. Yeah, pi underscore 4, so it's pi over 4. So now what should I do? Before I start my writing the equations or the code, I can call back the program constants.n. So constants, okay, yeah, here it is. So just then it's not .n, just whatever you called it for the variables as it is. So a over here is g by 2. I don't know why I imagine g by 1. In short story, like the lesson learned from here is you can create a set of constants or a set of certain values to call them back. Before you start your code, you're gonna need that a lot in the future. Before you start your code, just call it at the first. Then you know he's gonna recognize G, he's gonna recognize any other values in my code. Then you start to write whatever you want. When you hit run, he's not gonna complain about what is G, he's not gonna complain about Avogadro and so on.